Let's move on to our next method now, which is Ex-meridian. Now, first of all, the meaning of this method. X basically means close. So Ex-meridian basically means that the body is close to the meridian. It could be east of the meridian or west of the meridian, but it is close to the meridian. Now, practically, this Ex-meridian method is not used nowadays. It has almost lost its practical relevance because we have other methods which are available which can be utilized in place of Ex-meridian, like intercept. Intercept can be used in these situations where Ex-meridian is used, and it does not have any restrictions also. Ex-meridian method has some restrictions. It can be only used for a particular amount of time or for a period of time. So we have the better method available to us now, and nowadays we use that. But theoretically, yes, sometimes questions based on Ex-meridian, they drop in the papers. So we should be familiar with the working out of the Ex-meridian site. Let's now go into the method. I will also explain to you the relevance, practical relevance of Ex-meridian, how it is practically actually taken on board, and its comparison to intercept. So for that, let's first understand the procedure of how Ex-meridian method is solved. Let's see the information which is provided to us in the question. They will provide us the date and time. The time could be GMT or chronometer. In case of chronometer, there could be a 12-hour ambiguity, which will be resolved using the AM/PM indication given in the question. The second set of information is they will tell us that the body is close to the meridian or the body is near the meridian. Along with it, we will have the sextant altitude of the body, and as usual, the index error, the error of the instrument, the sextant, and the height of eye provided to us for dip correction. And we will also have the DR position given in these questions. This is the information which is provided, almost similar to what was there in long by chron or intercept, with only one addition, that a indication is given that the body is close to the meridian or near the meridian. Now, as far as our exam questions are concerned, wherever this indication is given, body is close to the meridian or near the meridian, the paper setter wants you to attempt this question using the Ex-meridian method. So this is the intimation provided to us to denote that Ex-meridian is to be used in these questions. So let's go into the procedure now. The first step is similar to what we have already done. We obtain the almanac information of the body. We get the hourly GHA, apply the increment, apply the V correction increment if required in case of planets and moon, and we get the accurate GHA of the body. We have the DR longitude available to us, and once applied to the accurate GHA, we get the LHA of the body, and this LHA gives us angle P. Now we obtain the hourly declination from the day page. We get the value of hourly decorrection. We check its increment from the increment table, apply it, and that gives us the correct declination, the accurate declination of the body. So this is the first step. Now in the second step, we correct the altitude of the body. The sextant altitude, we apply the index error. If it is on, it is put off, that means negative. If it is off, it is put on, that means positive. Then we apply the dip correction from the height of eye which is provided to us in the questions. And once these two are applied, we get the apparent altitude of the body. Now to this apparent altitude, we apply the total correction, and this gives us the true altitude of the body. Once true altitude is obtained, we can get the true zenith distance of the body, which is 90 minus true altitude. So once you have calculated up to here, you are ready to go into the intercept formula. Let's see the intercept formula. Intercept formula is cos of mzt is equal to cos of tzd plus 1 minus cos p into cos of latitude into cos of declination. Now let us understand the terms one by one. The first term which you see is the meridional zenith distance, that is the mzd. Now before I explain the remaining part, let me explain to you a little bit the relevance of Ex-meridian. I told you that nowadays it is practically redundant, but in the olden days the Ex-meridian method was in use. It was helpful to us, and the reason for that was that at the time of meridian passage, if there is any reason, cause or interruption because of which a Marpa site cannot be obtained. It could be that it was raining at the time of meridian passage, or the sun or the celestial body was covered with clouds. You could not take a sight at that particular instant. Now Marpas is an instant. So if you miss that instant, then the meridian passage sight is not possible. It happens only once in a day for the sun at the noon time. So if you miss that instant, the Marpa site cannot be obtained. Now it was very important in the olden days to get a Marpa site, because our passage calculation, which is also known as day's work, the passage calculation or day's work was based on the noon position, the Marpa's position, and we used to calculate the distance traveled, distance made good, engine speed, all these things, the distance remaining, what is the fuel. A noon report was prepared every noon, giving a full summary of the passage for the last one day, and it was sent to all the concerned parties, the owners, the managers, the charterers, all these parties. So if you missed the Marpa site, the day's work calculation will get affected. Nowadays, we are not bothered because we are getting a real-time position from GPS, and the day's work can be easily calculated from 1200 to 1200, whether you take a sight or not, whether there are clouds or not, whether there is rain or not. But at the olden times, when GPS satellite positions fixing was not there, this was the only method with which the day's work could be calculated. So in case a Marpa site was missed, the only other option available to us to get the MZD. See, the Marpa site gave us the MZD, meridional zenith distance. Then this MZD was combined with declination to get the observed latitude. So we wanted a way to get the meridional zenith distance in case the Marpa site was missed. And this is why the Ex-meridian method was used. So we can calculate the MZD, though it is not a Marpa site, it is taken before or after meridian passage. It is not a Marpa site, but still using this we can calculate the MZD, and this MZD can be combined with declination in the same way as was done in a Marpa's observation to get the observed latitude. So that was the whole purpose of Ex-meridian. So cos of MZD is equal to cos of TZD, that is the true zenith distance. It has been calculated already from the true altitude of the body, plus 1 minus cos of P. P is available to us. We had calculated the LHA, which gave us the value of P, into cos of latitude into cos of declination. The latitude used is the DR latitude. The declination is available from the almanac. So all the terms on the right hand side are available to us. We put them in the formula. Using the scientific calculator with a single step calculation, we can obtain the MZD. D. So this is again a very important formula, not to be forgotten. Make sure that you apply this formula correctly. Now, once you get the MZD, you can combine the MZD and the declination exactly in the same way as we did in a Marpas observation, latitude by meridian altitude observation. And once you combine them, we obtain the observed latitude. So exactly in the same way as we had the observed latitude, we get the observed latitude. Now the combining was by giving a name to the MZD. We had done a shortcut method. You first give name to the true altitude. The name to true altitude is the same as the azimuth of the body in whichever direction the body is. North of the observer or south of the observer, the same name is given to true altitude, and opposite to that is given to TZD as well as MZD. So once the MZD name is there, you have the declination name given in the almanac. Same names you combine, opposite names you subtract the smaller one from the bigger one and retain the name of the bigger one. It gives you the observed latitude. Now up to here, this was similar to the Marpas observation, but after this there is a difference. The difference is, number one, the observed latitude which we got in a Marpas observation was also the fixed latitude. The observer has to be somewhere on that latitude only. But in this case, the observed latitude is not the fixed latitude. Why not? Because in this case, the azimuth of the body is not exactly north or south. The azimuth is close to north or south, but not exactly north or south. Because the body is not on our meridian, the body is close to the meridian. If the body was on the meridian, azimuth will be north or south, and the direction of the PL will be exactly east-west. Anywhere on that PL, you will be on the same latitude. But in this case, the body being not on the meridian, azimuth will not be exactly north-south. Similarly, the PL also will not be running exactly east-west. It will have some different direction. And that is why, depending upon where you are on the PL, the latitude is going to change. I will show you with the diagram also in the next slide. But to remember, the observed latitude, what we get in the ex-meridian method, is not our fixed latitude. Then how do we use it to obtain the position line of the observer? So for position line, we have to calculate the azimuth of the body. The azimuth, as usual, will give us the direction of the position line, and we will plot that PL on the chart. So for azimuth, we use the ABC method. A is equal to tangent latitude upon tan P. B is equal to tangent declination upon sine of P. We combine both of them to obtain the value of C, and then we use it in the tan azimuth 1 by C into cos lat formula to get the azimuth of the body. Once the azimuth is obtained, we know that the position line is perpendicular to the azimuth of the body. So we have obtained the azimuth and we have obtained the observed latitude. These are the two data items which are required to plot the position line. Once these two are known, we can plot this PL on the chart or in our plot. Beta, any doubt up to here? You have the full procedure now on the screen. So any doubt in any of the steps, please share with me.
सर ये जो ऑब्जर्व्ड लैटिट्यूड आता है इस मतलब उससे मेथड से, इट इज नॉट ए फिक्स्ड लैटिट्यूड सर, क्यों सर?
बेटा अभी हम ना इसकी डायग्राम बनाएंगे यूजिंग द इंफॉर्मेशन, तो उस डायग्राम से आपको पता चल जाएगा दैट दिस ऑब्जर्व लैट इज नॉट द फिक्स लैटिट्यूड। मैं अभी बनाऊंगा नेक्स्ट स्लाइड में।
ओके।
और बेटा एनी मोर डाउट? Okay, great. Let's proceed ahead now. We will make a diagram and we will see it further. Let's see the X-meridian plot in the diagram. Now, the reference position where the X-meridian PL is plotted or drawn or passes through is the DR longitude and the observed latitude. So this is the reference position, observed latitude, which we calculated from the Marpass formula, the X-meridian formula, and the DR longitude. This is the position from where the PL is going to pass. Now, after plotting these two, we plot the azimuth of the body. The body is close to the meridian, so let's assume our celestial body is here. The direction in which the body is represents the azimuth of the body, and perpendicular to the azimuth is going to be our PL. So the green color line with arrows on both the sides represents the position line or the LOP. Now you can see that the observer or the vessel can be anywhere on this PL, and if it is at any point on this PL, it is possible that the fixed latitude may be different from the observed latitude. Observed latitude just gives you a reference position from where the PL is passing. It does not give you the fixed latitude in this case. So depending upon where you are on this PL, which we will find out when we have a second PL, wherever the second PL crosses it, that will be our fix. So depending upon at which point you are on this PL, the latitude is going to differ from the observed lat. So this is the X-meridian plot. Beta, I hope now it is clear why observed lat is not the fixed lat.
Yes.
Okay. Once more, you want me to explain once more?
Yes, sir.
Okay.
Yes, sir.
देखो बेटा, एक्स मेरिडियन से जो ऑब्जर्व लैटिट्यूड हमें मिला है, that is just a reference latitude which gives us a position from where the PL passes. हम लोग ऑब्जर्व लैटिट्यूड और DR लॉन्जिट्यूड से वो पोजीशन निकाल सकते हैं जहां से PL पास कर रही है. Now once you obtain that position, on that position you have to draw the azimuth, like we have drawn the azimuth of this red color star, and perpendicular to the azimuth will be our position line. The body in this case is not on the meridian of the observer. So if it was on the meridian, the PL also will be east-west. But since the body is not on the meridian, the PL is also not exactly east-west. अब अगर आप PL पे कहीं भी हो सकते हो, then depending upon which place you are on the PL, your latitude would be different from the observed lat. जो PL है वो ऑब्जर्व लैट के ऊपर भी जा रही है, नॉर्थ में भी जा रही है, साउथ में भी जा रही है. तो PL पे आप जहां पर भी हो, आपका लैटिट्यूड ऑब्जर्व लैट से अलग भी हो सकता है. डिड यू अंडरस्टैंड इट बेटा?
Yes, sir.
ओके. एनी मोर डाउट्स?
No, sir.
Okay beta, great. Now beta, as far as the calculation is concerned, you will be able to solve the X-meridian questions with this much of information. But let me give you a little more idea about the Ex-meridian tables. These tables are not used nowadays much, but in the olden days the tables were very much in use. So let me familiarize you with the tables a little bit so that you can use them. These are there in the Norris tables. Now, one important thing not required right now in these Ex-meridian questions, but the concept should be clear in your mind. It will be used in star identification question. The concept is used in star suitable for site questions, and may also be asked to you in orals. Now, I told you that this Ex-meridian method is used when the body is close to the meridian. Now, the next doubt which comes to the mind is, how close is close? Somebody could feel if the azimuth of the body is 355, it is close. And somebody would say, no, it's gone far away. The Marpas azimuth should be 000 or 360, it's at 355, it is too much. So how close is close? Or in other words, what decides whether a body can be observed and the site can be solved using the Ex-meridian method at a particular time or not? Now, I also told you that this Ex-meridian method has some restrictions as compared to the intercept method. Intercept method does not have any restrictions at all. It can be used at any time other than the Marpas. The Ex-meridian method, on the other hand, has some restriction. It can be used only for a certain period of time. To give you an example, let us say if the meridian passage of the sun was at 1200. Now, for using Ex-meridian, there is a particular band of time, a period of time in which it can be used. Just to give you an example, if that band or period is 15 minutes, so 15 minutes before Marpas and 15 minutes after Marpas, that is the period in which Ex-meridian can be used. If the body has gone outside that period, the time has moved outside that period, the Ex-meridian method cannot be used in that case. What should be used in that case? The choice is intercept method. So if the body has gone out of this limit, then we can use the intercept method. Now, how to find the Ex-meridian limit? For finding the Ex-meridian limit, we have the Ex-meridian tables. They are there in the Norris tables. Let me show the tables to you. You can see the Ex-meridian table 1 on the slide now. There are total 4 Ex-meridian tables, table 1, table 2, table 3, and table 4. In the olden days when we did not have the calculators, then all these 4 tables were used to work out a Ex-meridian site. But nowadays the calculations are done with scientific calculators. So we do not require table number 2 and 3. Their purpose is solved using a calculator, but we require table number 1 and table number 4 to obtain the Ex-meridian limit. So let us see now, how do we obtain the Ex-meridian limit for a particular body? Now, if you see in this Ex-meridian table number 1, you can see on the horizontal axis we have the declination. This is the declination of the celestial body whose site is being taken. And on the vertical axis, you have the latitude. This is the latitude of the observer. So this table is entered using the latitude of the observer and the declination of the body. Now let's assume that the declination was 40 degrees and the latitude was 10 degrees. So 10 degrees latitude and 40 degrees declination, the table gives us a value of 2.96. This is also known as factor A. You can see it here. It is mentioned as factor A. So we have obtained the factor A from Ex-meridian table 1. In this particular example, we have taken 40 degree declination and 10 degrees latitude, and it comes to be 2.96. After obtaining this factor A, we enter into table number 4. You see the table number 4 on the slide now. This is Ex-meridian table 4. So in this table 4, we enter with the factor A, which we got from Ex-meridian table 1. So you can see this table gives the limits for using the Ex-meridian tables. The limit is in minutes of time before or after meridian passage. So you can see the factor A mentioned in this column, starting with 30, 25, 20, 15, so on, and going up to 0.7 in the last column. And with this factor, you have the maximum interval given in minutes of time. So let's try to find out the limit for our example. We had the factor A as 2.96. So you see it starts with 30, 15, 10, 7, go in the next column, 6, 5, 4, 3.5, 3, 2.8. Now the value which we have nearest to our value was 2.96. The nearest one which we have here is 3.0. So 3.0 gives us a limit of 32. This basically means 32 minutes before or after meridian passage. So it tells us that 32 minutes before Marpas and 32 minutes after Marpas is the time period in which the Marpas method, the Ex-meridian method, can be used. So if our Marpas was at 1200 hours, 32 minutes before, that's 11:28 and up to 12:32. From 11:28 to 12:32, the meridian passage, the Ex-meridian method can be used for obtaining a position line. If the time has gone outside this window, let us see, it is 12:33 now. So it has gone outside the Ex-meridian limit. This is known as Ex-meridian limit, in short also known as EML. If the body or time has gone outside the Ex-meridian limit, then this method is not recommended. This method will give us substantial errors. It is not recommended, and we should not be using this method then. In this case, we should be using, if the body has gone outside the Ex-meridian limit, we should be using the intercept method instead. So this is how we determine what is the Ex-meridian limit for a particular body and for a particular observer.
बेटा go ahead बेटा.
सर जो आपने ये मेरिडियन पेजेस का जो टाइम बोला है, तो जो डेली पेजेस में जो बॉटम में जो टाइम होता है वही टाइम हम लोग मानते हैं.
That's right beta, that is the LMT meridian passage. So let's say you are trying to look for the limits for the sun on a particular day. You pick up the LMT meridian passage from the almanac, bottom of the right hand side page, and then you add and subtract these two, the limit, and you will get these two times within which a Ex-meridian site can be taken. That will be LMTs.
Okay sir. सर LMT को हम लोग आफ्टर LIT अप्लाइंग हम लोग GMT मिल जाएगा और उसमें हम लोग जोन टाइम ऐड करके, तो गलत होगा?
नहीं बेटा, फिर भी सही होगा
सर. वही हम लोग एक्चुअली करेंगे ना सर.
Yes, because see, when you are on a ship, you are maintaining a certain time zone, a certain difference from the GMT. Let us say you are maintaining GMT +4. Okay, on a particular day you are maintaining ship's time as GMT plus 4. So अब आपको जो लिमिट चाहिए वो तो अपने शिप्स टाइम के हिसाब से चाहिए ना. सो व्हाट यू डू इज़, जो LMT आपने एल्मनैक से पिक किया है उस LMT को पहले GMT में कन्वर्ट कर लो बाय अप्लाइंग द लॉन्जिट्यूड एंड टाइम. सो वंस यू हैव द GMT यू अप्लाई द डिफरेंस प्लस 4. आप अभी GMT प्लस 4 मेंटेन कर रहे हो. So when you do that, you will get the ship's time of sun's meridian passage. अब उस टाइम पे अगर आप ये लिमिट को प्लस और माइनस कर दोगे तो तुम्हें एज पर यूर शिप्स टाइम पता चल जाएगा कि कौन सा वो पीरियड है जिसमें एक्स मेरिडियन मेथड यूज़ किया जा सकता है.
सर फिर वो जो LMT जो मेरिडियन पैसेज है, खाली अगर उसी को यूज़ करना है तो वो कब करेंगे सर?
नहीं, आई डिडंट गेट यू बेटा.
सर जो डेली
हमारे पास
बेसिस
वाले क्वेश्चन में
ओके सर, जो LMT है, सपोज हम लोग को LIT और वो जोन टाइम नहीं लगाना, तो LMT जो मेरिडियन पैसेज का जो टाइम दिया है सर टेबल्स में, तो वही हम लोग खाली वही यूज़ नहीं कर सकते?
अगर बेटा वो यूज़ करोगे तो लिमिट भी LMTs में ही आएगी ना. अगर आपको लिमिट LMT में चाहिए तो आप सीधा उस पर लिमिट अप्लाई कर दो. अगर आपको लिमिट शिप्स टाइम पे चाहिए तो LMT को शिप्स टाइम में कन्वर्ट करके फिर अप्लाई कर दो. इट इज़ बेसिस योर रिक्वायरमेंट.
ओके सर.
ओके. और बेटा और कोई डाउट अभी तक इन द टेबल्स और इन द मेथड?
सर ये
सर ये
जो
जो फॉर्मूला, तो जो फॉर्मूला आपने सर जो लिखा है ना सर, ये कोस MZD इक्वल्स टू कोस्ट TZD, और सर उसमें 1 माइनस कोस P में जो P है वो एंगल है या LHA है?
बेटा
मतलब
वो एंगल P है. If LHA is less than 180, it will be equal to LHA. If LHA is greater than 180, it is 360 minus LHA.
ओके सर.
ओके.
सर
और बेटा
सर ये जो टेबल है
सर ये जो मेरे
एक्सपेरिडियन
पास
का,
राइट.
सर जो बुक में दिया गया है उसमें सर 1 2 3 टेबल तीनों यूज किया है
हाँ
इसमें.
ओके बेटा, जो टेबल नंबर 2 and 3 है, as I told you, they were used to avoid calculator. क्योंकि पुराने टाइम में हमारे पास कैलकुलेटर्स नहीं होते थे. सो वी यूज टू डू दीज कैलकुलेशन यूजिंग टेबल 2 and 3. फिर उसमें से एक रिडक्शन मिलती थी, हम उसे अप्लाई करते थे. बट नाउ वी हैव कैलकुलेटर्स, सो वी डू नॉट यूज टेबल 2 and 3.
तो सर ये रिडक्शन क्या है सर, वो वही है कि दूसरा है, वो TZD वाला है ना वो तो?
नो बेटा नो, ये जो रिडक्शन है इट वाज यूज्ड व्हेन देयर वर नो कैलकुलेटर्स. नाउ विद कैलकुलेटर्स यू फॉरगेट अबाउट रिडक्शन.
ओके सर. तो एग्जाम में सर ऐसे डायरेक्टली 1 और 4 लिख के उसका लिमिट लिख देंगे फिर?
यस दैट्स राइट बेटा.
सर ये जो मेरे पास टेबल है इसमें ये दिया हुआ है फैक्टर A एंड R एंगल.
राइट.
R एंगल्स थी वही वाला है सर, सेम ना?
हाँ बेटा, इट इज़ द सेम. इट इज़ द सेम. सी, इसमें ये दे रखा है ना फैक्टर A. इट इज़ बेसिकली चेंज ऑफ एल्टीट्यूड पर मिनट.
वो जो टेबल 4 है सर,
हाँ टेबल 4. यस.
ये इसमें सेम यही है सर, फैक्टर A एंड R एंगल दिया हुआ है जो नॉरिस टेबल है मेरे पास.
You have the angle, sorry, factor A and the R angle.
Yes sir, Ex-meridian table 4.
Can you take a picture and send me better? Or you can show it here.
Okay sir.
You can post it here in the meeting also, wherever you feel comfortable.
Okay sir, just a moment.
Let me see.
Just a moment.
Yeah.
So just a moment, let me pin it. Can you see this one, sir?
Okay. Beta, it is the same. It is the same. The R angle word is mentioned here just because of the change in addition. Otherwise, अगर तुम टेबल के ऊपर देखोगे ना बेटा, टेबल के ऊपर
जी सर।
को ये लिखा हुआ मिलेगा, लिमिट्स फॉर यूजिंग एक्स मेरिडियन, मिनट्स ऑफ टाइम बिफोर और आफ्टर मेरिडियन पैसेज, राइट?
Yes sir, that's right sir.
Right, so it is basically the minutes of time beta.
Okay sir.
Okay,
सेम ही है सर फिर तो।
yes, it is same.